Hi, this is Sunny Solanki and you are tuned to Coders Column. In today's video, I will explain how to build an object detection web app using Python library Streamlit. Nowadays, Streamlit is one of the most used libraries to create dashboards and small web apps using Python because it requires a fewer lines of code to create and maintain app using Streamlit, and the app looks nice as well. Now for our purpose, we will be creating a simple app where user can upload an image and the app will detect list of objects present in it. The app will add bounding box around each detected object and adds a label as well. Now for detecting objects, we will be using a pre-trained object detection model named Faster RCNN, which is available from PyTorch in our app. So first of all, let me show you the app that we are going to create before we start with the coding part. So as you can see on my screen, I have a sample image of how our final app will look like. So at the top, I have a file upload widget using which we can upload an image. So I am currently allowing PNG, JPG and JPG images. So once we upload the image using this widget, the app will use the pre-trained model to detect the list of object present in it, and then we will add bounding boxes and labels to the uploaded image and display it on the screen. Below that image, we will also display prediction probabilities of each detected objects. Now this part is optional. If you want to include it, then you can include it, otherwise it can be ignored. All right, so that's the app that we are going to create. Let's move on to my IDE where we will start with the coding part. Alright, so as you can see on my screen, I have my Visual Studio Code editor open. So I will be coding in this editor, but you are free to use any other editor which you are comfortable with. Now as you can see, I have already created a file name object detection app.py. So we will be keeping the code for our app in this file, and I have already some lines of code present in this, so we'll be using this line of code. So let me first of all explain you the code that I have already present. So I have at the beginning few imports. So I have imported Streamlit and then PIL image and matplotlib, and below that I have imports for torch and torch vision. So we'll be using a faster RCNN model which is available from Torch Vision, and we have also imported the weights. So the weights are of the model is trained on a dataset named Coco dataset. So all right, so model is trained on a Coco dataset, and this function which you see, which is imported from Torch Vision utilities, draw bounding box. So this function will let us add bounding boxes around the detected objects. So let me show you the Coco dataset website. So model is trained on this dataset Coco, which is like 330k images and 1.5 million object instances. And yeah, the dataset has 80 different object categories. So the model that we are going to use will detect one of the 80 objects. So objects present in these 80 categories will be detected if they are present in our image. All right, so let me go back to editor again. So as you can see, first of all, I have kept the weights in this variable name weights. So by default, it will use Coco weights, the weights of the model trained on Coco dataset. And this weights object or variable is a enum object. So it's a kind of a dictionary. So it has information about URL from where the weights of the model will be downloaded, and few other things about the weights, like which categories are present. So over here I am calling weights.meta. So that's another dictionary in these weights where information like categories is present. So as you can see, I have highlighted some of the categories over here, like it will detect background, person, bicycle, car, motorcycle, airplane, and there are 80 categories as I told you earlier. So that will be stored in categories variable, and then from this weights I have called transform function. So this function, and I have stored it in image preprocess variable. So this function is applied to image before it's given to our pre-trained model for detecting objects. What this image preprocess will do is that it will prepare an image for the model. So basically it will transform the input PIL image, pillow image, to tensor, PyTorch tensor, and it will also scale values. So by default, PIL images values in the range 0 to 225, the array of the image. So it will scale it to range 0 to 1. So that's what image preprocess does. Next, I have a simple function named load model. So this load model function will load our models. So over here, I am calling this faster RCNN, ResNet, FP and version 2. Then I am over here giving weights. So weights is this weights we loaded earlier. And then I have set this parameter box core thresh to 0.8. So what this will do, it will detect objects for which model has probabilities of more than 0.8. So yeah, that's what it will do. It won't include the objects for which model has less than 0.8 probabilities. And then I have set the model in evaluation mode for making prediction. Yeah, and then we return the model. So next line of code loads the model. And then I have a function which makes prediction. So this function takes as input PIL image, and on that PIL image we apply the transformation image preprocess which we loaded earlier, and then we give this processed image to our model. And as you can see, before giving the image, I have called this unsqueeze 0. So what this will do, it will add one dimension at the beginning. So let's say that our image is 500 by 500 pixel. So after this pre-processing, let's say the image shape becomes 3 by 500 by 500, because we'll be using RGB image and it has 3 channels. So it will become 3 by 500 by 500. And when we call unsqueeze on that, it will become 1 by 3 by 500 by 500. So basically I am adding a batch dimension over here, because majority of models are trained on a batch of images and they make prediction on batch of images as well. So output of this is our prediction. So over here I have called prediction of 0. So it will return, because in our case we have only one image, so that's why I have called prediction of 0. If you are giving more than one images, then this prediction will have list of those images outputs. So now this prediction is a dictionary, and it has 3 keys: boxes, labels and scores. So boxes are bounding boxes. So these boxes will be tensors which has the same shape as our image. So let's say 500 by 500, but it will have information about boxes of the detected objects. Then we have labels. So labels will be integer like 0, 1, 2, 3 and so on for list of detected objects. And those integer we will use in this categories dictionary, categories list, to retrieve the actual name of the object. So if our model detects person is present in it, then over here as you can see person is present at index 1. So over here in labels there will be value 1, and this category is using this category we will convert that 1 to person label. And scores is probability for each of that detected objects. So from this function we are returning the prediction dictionary which will have those information boxes, labels and scores. Now this next function is create image with bounding boxes. So what this function does is that it takes our original image as input and the prediction is input, and then it adds the bounding boxes around our original image and returns it. So first of all we are converting our original image to tensor. So I will be giving over here numpy image, and then I am giving this tensor to draw bounding boxes function which we loaded earlier from Torch Vision utilities module. So first argument to this function is the tensor, our original image. Then to boxes we are giving list of boxes from prediction, and then we are giving labels, and then we are setting colors. So in case of colors, what I have done is that I'm looping through labels, and if the label is person, then I am setting color as red, else for all other objects the color will be green. So that's all. And the width of the line or bounding boxes is set to 2. Now in the next line, so the output of this function raw bounding boxes will be again PyTorch tensor. So I am on that PyTorch tensor, I am calling detach to detach it from a graph of PyTorch, and then I am calling numpy to convert into numpy, and then I am transposing it back to channels first format to channels last format. So all the PyTorch models and methods work with the image where channels is presented first, so 3 by W by H. But when we want to display it on our dashboard, we'll be using matplotlib, and it requires that image has channels data presented last. So that's why I'm converting it from 3 by W by H to W by H by 3 format, and then we will return this image with bounding boxes. Alright, so these are the 3 functions which we will use. So let's get started with the coding part. So first of all, I will add title to our dashboard using title function. So I will say object detector, and then I can add emojis as well in the title. So I will say tea and coffee, and we can add emojis by putting the emoji name text in this columns, 2 columns. And there are many different emojis available from Streamlit. You can go and check the documentation of Streamlit if you want to add different emojis. So next, I will use the file uploader widget. So I will set label to upload image here, and then I will set type parameter to PNG, JPG, and JPEG. So the result of this I will store to upload. So whatever image that we upload using file uploader widget will be available in this variable upload as a byte. So if upload is present, so if some image is present, then we will run our model, make prediction and display it. So that's why we have if condition over here. So now if image is present, so first of all, what I will do, I will use image.open. So this is image from PIL, which accepts the byte string as input, and it will create PIL image from it. So now that we have created an PIL image, next what we can do is that once we have PIL image ready, we can give it to this make prediction function to make prediction. So I will give it image, and that will output prediction. So now this prediction is a dictionary, as I said. So now we have a made prediction on our image. Next we can call this function create image with bounding boxes, and over here first of all I need to give image, and second is prediction. But before giving the image I need to do some transformation. So this function accepts numpy array as image. So I will call numpy mp.array, and what this will do, it will convert our image from PIL to numpy array. Now I need to also transpose the axis of the image. So by default, when we convert this pillow image to numpy, it will be in the format of W by H by 3. But as I said, our PyTorch functions and models requires us images in the format 3 by W by H, channels first. So I will have to do transpose over here. So I will do 2. So second axis will be first, so which is the channels axis, and then 0 and then 1. So output of this will be image with bounding box. So now that we have made prediction on our image, and we have the original image with bounding box as well, so let's go ahead and display this image in our dashboard for our web app. So first of all, so we'll be using matplotlib for displaying image. So I have already imported pyplot API of matplotlib. So first of all, I will create a figure object. I will set figure size to 12 by 12, say, call it figure. I will create axis object figure dot add subplot, and next I will call plt dot imshow to display our image. So I will say image with bounding boxes. So now matplotlib will add axis labels and all that as well. So I will remove x ticks and I will remove y ticks as well. And apart from that, it will add a box around the whole image as well. So I will disable that box as well by calling axis object dot spines, and over here I need to give names of the spines. So I will say top, bottom, right, and left. And on this I will call a method name set visible, and I will set it to false so we don't see the box around our image. Right, so now that we have created the matplotlib image, now in order to add it in our dashboard or app, I will use a pyplot function which is available from Streamlit, and it accepts a matplotlib figure. So I will give our figure object and I will set this parameter name use container width to true. So this parameter expands and shrinks the image based on the width of the container. Right, so now that we have displayed our image as well with objects detected with bounding boxes and labels, so next we can display that probabilities as well. So first of all, I will add header. So I can use a header function to add a header. I will say predicted probabilities. Now this is optional. If you want to include it, then you can include it. And from prediction, I will display b box as well. Boxes this, because we don't want to display bounding boxes. We only want to display the probabilities and labels. So I will say st.write and then prediction. All right, so we are done with the coding of our app. Now let's go ahead and test it. So I will go ahead and click on terminal and we'll start a new terminal over here. Right, so I have saved this file in a folder named YouTube tutorials and object detection dashboard. Now in order to run a Streamlit app, we need to execute command streamlit run and then name of the app. So I have saved it in a file name object detection app.py. So once I execute this command, it will start a new server over here, and then it will open a new tab in the browser where our app will be displayed, and then we'll upload an image and test it. So let me execute it. All right, so the server has started and the new tab is open in the browser and it is running our app's code. So let's see. Okay, now it's running a load model function. And yeah, so as you can see, we have a title over here and we have a file upload widget using which I will upload an image. So let me call on browse file. So I have some images already present. So there is an image of holiday over here. So let me open this. There is a 4 persons present in this image. So let me click open. So now as you can see, it's running. And now the app is using the trained model to detect the list of objects, and the result will be displayed over here. Okay, so there is a minor mistake in the spelling. So let me just correct it. So over here, the name is transpose. So that was a minor mistake. So let me go to our and click on rerun. Yeah, and now we have our resulted image. As you can see, it detected 4 person. And yeah, this one is not frisbee, but still. and this is not baseball glove as well. So yeah, model is not that accurate, it does make mistakes. Yeah, and below that we have various labels: person, 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 recipe, and probability of all those labels, right? So let's go ahead and try few other images. So next I will try this kids image. So this takes little amount of time. Yeah, we have our image. So as you can see, it has detected all the 4 persons present, all the 4 kids, and it also detected this sports ball. And there we have detected objects and their probabilities. I have one more image. Let's try it. Over here I have image of family eating cake. So dad and daughter eating cake. So let me open it. And yeah, as you can see, it has detected majority of the object, but as you can see, it's detecting this one as a toothbrush where it's a spoon, and this spoon is not detected. But it detected 2% potted plant and 2 balls over here. It did not detected these balls as well. So in order to let the model detect more objects, what we can do is that we can make one minor change in our code. So when I explained the part where we load our model over here in this load model function, as you can see, I have set this box score threshold to 0.8. And as I said, it will include objects for which model has probability of 0.8 or more. So what I will do, I will set this probability to 0.5 so that it detects more objects which are present in our image, but it might not be that sure about those objects. So now that I have made changes, let me just rerun the code. So as you can see over here, it's saying source file change. And once I click on rerun, it will rerun this image. And let's see whether it's adding more objects or not. Yeah, so now as you can see, as we decrease the required probability, it detected more objects. So it detected vase over here. It detected spoon over here, detected spoon over here as well. And this ball, which it was not detecting, it detected that as well. And over here, it's detecting wine glass as well. Yeah. So as you decrease the probability, you can detect more objects. Now, so we are done with our tutorial. Now let me bring few things to your attention. So first thing is that this kind of model takes lots of memory. So as you can see on my screen over here, it has used 10 to 11, around 11 GB of my available RAM, because I am running this model on CPU. But if you have a GPU available, then you should run this model on GPU so that your CPU RAM is free. Yeah, so that's the one thing. And if you try big images with very high resolution, then I guess that even 16 GB won't be enough. 16 GB of RAM won't be enough for those images. It will most probably hang your computer. So keep this thing in mind when you are using a big model of object detection and image segmentation and so on. Other than that, in our tutorial, we tried this model faster RCNN, but there are other pre-trained models available from PyTorch, which are FCOS, RetinaNet, SSD, and so on. So you can try these models as well if you are interested. And if you want to learn about PyTorch object detection, then I would recommend that you visit our website. There we have a tutorial on PyTorch object detection using pre-trained model. So then you will be able to use different models. And yeah, one more thing. Now in our case, we used PyTorch. In the Torch Vision module available from PyTorch to detect objects. Now other than Torch Vision, there is a library named GluonCV that can also be used to detect objects present in our image. So MXNet is another deep learning framework like PyTorch from Amazon, and it has a library named GluonCV, which is computer vision library of MXNet, just like Torch Vision is a computer vision library of PyTorch. So if you're interested, you can visit this tutorial of GluonCV, and you can use GluonCV to detect objects as well. So it's a nice library as well. and you might find that it's detecting object more accurately. So yeah, feel free to explore. Alright, so that's it for today's tutorial. If you liked our video and you feel that you learned something new today, then give it a thumbs up, subscribe to our channel, and yeah, see you next time.